Good morning and welcome to our sunrise stream. Today's kind of a test. I'm still working out the equipment, but I was just checking out what we caught, and we got some great wildlife. Hopefully the nature sounds are good. I got a new microphone. I got some cables coming, a new camera, a GoPro, and so we're working this out. I'm figuring it out. I'm gonna get up early and we'll see what kind of quality material we can get. But I also want to use this as an opportunity to do some response videos. As I'm making my videos, I am referencing continuously other videos on the internet, and that requires me to upgrade into this very popular type of video, which is the reaction video. And then later I can clip from all these videos that I'm making and edit it all together. That's the goal anyway. We're gonna put together frameworks and understand how this is going. Also, I plan to do this as a stream, so I'm figuring that out. I clicked to stream this morning, and I can do it in tomorrow. It looks like we'll see if we can make tomorrow happen, and I'll slowly get it figured out. But one of the first things I really wanted to talk about
the next layer
was
in the design process that
steep slopes. I saw this great video, Permaculture Design for Slope, and it really encompasses everything that I have noticed is the problem with slopes. In the literature, in the milieu of ecological restoration, permaculture especially, the reality of slopes is different when you get to, let's say, the Andes Mountains and really mountainous regions. I'm imagining Tibet. In fact, Andrew Millison here does such a great job at recognizing the deficit of the permaculture theories behind slopes. And so we're going to try to go through this, and we're going to talk about it as we go on. The realities
that we will look at is design for slope.
This guy talks really slow.
We've already looked at the permaculture zones and sectors, and both of those design tools use somewhat of a regular pattern. The zones being a concentric circle pattern, and the sectors expressed as pi wedges on the sector compass. But the fact is that hardly any sites are actually so regular that these geometric templates fit neatly over them. The truth is that the topography of the Earth is infinitely varied.
So this is a really important part, infinitely varied. And as we get into this concept of Stardew Valley in real life, we're going to see that these infinite variations are going to give us opportunities, also challenges. And but permaculture recognizes this, right? These conceptual circles are just that, they're conceptual. You have to apply these templates and strategies in real life on real land with varying characteristics. And one of those is slope.
And each site has unique variations of climate, microclimate, soil, aspect, slope, water flow, hydrology, wind direction, et cetera, et cetera. It goes on and on. Each site is unique. So the permaculture design process continues on beyond zones and sectors. And the next design layer that we're going to look at is slope.
Now, one thing that I think doesn't help the permaculture people is the order in which these things are in. We're going to move beyond zones and sectors into the things that are really matter. So it's almost like when you start in permaculture, like, oh yeah, all of this is solved. All I got to do is overlay it. But when you're coming into a place that's infinitely varied, and you're trying to overlay, you're trying to force in your model, some challenges can occur. And so in our case, right, we're 11 years in, and just now we're going through and putting together all of our ideas and observations over the last 11 years in our zone 0 and zone 1. We're going through and finalizing the different sectors of these close to the house zones. It was much easier to start further away from the house because there's maybe less risk, easy to change, there's less buy-in. Whereas if you build a house, that's thousands of dollars. And if you want to move it, if you put it in the wrong place, well, those observations really need to be on point. You might want to take a little longer to do those.
On a compass that is 360 degrees all the way around, 1/4 of that is 90 degrees.
So he's going to start drawing some slopes. Let's see what we notice. Let's notice what we can, remembering that, for example, I'm in the Andes Mountains. Let's take a look at his slope drawings and see what we can learn.
A slope that bisects that is 45 degrees. That 45-degree slope represents an equal rise and an equal run. So if a completely flat slope is 0%, and a straight up and down slope is 100%, then half of that is a 50% slope, which is the same thing as a 45-degree slope. Now the third way to
So this is just a jargon, like there's different ways to qualify slopes, to talk about slopes. He's going to talk now about proportionality. This is academic, but interesting. If you want to ever talk about slopes with other people, try to explain exactly how steep your slopes are. You'll need to know some of this nomenclature.
express this same slope is as a ratio h to v, or horizontal to vertical. So this slope has an equal horizontal to vertical measure. So it is a 1-to-1 slope. Now all those different ways are used to express slopes. It really varies by country, by discipline, and by the situation. But for this lecture and throughout the course, I will primarily use percentages. Right? I personally find the easiest way to conceptualize a slope is in percentages. And I'm going to draw, and I've drawn this grid here to do my drawing on top of so that we can better conceptualize the slope for this module. Now, we're going to start by looking at how people practice different land uses on different gradients of slope. This is a 75% slope, and is about the maximum slope that we see in the world that anyone has cultivated for agriculture.
So here I am represented. These 75% slopes, we have them. We have 45 to 75 percent slopes, and we cultivate them all the time. I came in to Colombia, and they were already being cultivated. So I didn't invent this.
In some areas of China, Vietnam, the Philippines, we find terraced rice paddies built on these slopes at a great expense of effort, as well as tea plantations when we look around. So terraces on this kind of slope also exist in Peru and the Andes Mountains and probably other places in the world. I haven't looked everywhere. I'm not totally sure about all of them. But in order to terrace a slope like this, you need a really tall terrace wall to get a small growing area. This is an incredible amount of work for not a great deal of space, as you can see. So only civilizations who have really limited arable lands with great population pressure and a surplus of labor and resources would undertake such a project. It's actually pretty...
This is interesting because this is not the case in Colombia. We'll get back to this and what assumptions he's making here. But we can start at this level of understanding because this is what most permaculture strategy, people from Australia and then United States and Europe have thought about it, right? 75% slope, that's ridiculous. We'll leave out the fact that we do it here. Without great expense and without heavy population pressures and without capital investment. But let's see what, the current thinking on slopes is right now.
Pretty mind-blowing to think of the civil engineering involved in these hand-built projects because there's a huge risk of destabilizing the slope with work like this. Now, it's a lot more common to find paddies and terraces at more like a 50% slope. That's still considered very steep, but I'll show you what that looks like. And you can see here, the ratio of wall height to terrace width gets better as the slope becomes more gentle. Now, you wouldn't have a terrace wall. It was completely vertical anyway. You'd have it on a slight slope. But I'm just drawing the geometry of it, not an actual construction document here. So people are cultivating extreme slopes all over the world. But that doesn't mean it's ideal when we look at the whole watershed system and what the optimum uses of different slope gradients are. Now, in the Permaculture Designer's Manual, Bill Mollison advocated that any slope steeper than 20% be kept in permanent forest for permanent soil stability and for a number of other reasons.
So this is the important part here that I wanted to talk about. Bill Mollison, who invented permaculture, he put in some guidelines, right? Anything more than, did he say 30%, 20%? permanent forest. Now, of course, that doesn't mean you can't cultivate a permanent forest, but we'll get to that point as well. But basically, we have this whole system of design, supposedly for the whole world, although some areas and some climates have better developed strategies in permaculture. But advocating that basically my entire farm should just be forest, kind of abandoned to nature, and good luck because it's way too steep. And so this is really interesting, right? This 50% gradient is approximately what our Tangara lot is. We have sublots Tangara 1 through 8. And it's a beautiful little section that we've done probably some of the most work on. And it's about a 50% slope. That's the least steep of some of our zone 3 and 4 lots that we're working with. So just to give you some idea.
Now, I've drawn a 25% slope for ease. You can see it's 1 to 2. You can see how the 75% slope for the same rise of terrace, you get 1 unit of horizontal space. On the 50% slope for the same rise of terrace, you get 2 units of space. And then on the 25% slope for the same rise of terrace, you get 4 units of horizontal space.
So this is really interesting. I mean, this is just geometry, right? But remember the assumptions of a terrace wall. So it's interesting why we don't use terraces. They are expensive. They're all the things he said. And that math checks out. If you go straight up, and really, like you said, you're not going straight up, you're going on a slight angle, and then you're creating flat space. That's maybe important for rice, right? You got to be able to flood it. But we don't need that inner space to be flat. We can get way better numbers here if we use, for example, our biomass contours. We have no terrace walls, but we're making biomass barriers. And those biomass barriers are sprouting with biodiverse species, where birds and mammals can use the space. And then the cultivated areas between those contours are sloped, and so we're not stopping the water because there is a big risk of destabilizing soils. We're just slowing it and spreading it and making sure it steps down and doesn't, has a break, a fluid break. And so some of his assumptions you can see are, if you make those assumptions, this makes sense. Let's not cultivate on steep slopes. But we're already doing it, and in those areas where it does make sense, why does it make sense? Obviously, we have different assumptions than permaculture.
Okay, so permanent forest does not mean it's an unproductive landscape by...
This is important because obviously permaculture knows that a permanent forest is not unproductive. And that is up for a lot of work in the future as we design productive forests. I'm not saying that you shouldn't have trees. Obviously, we have agroforestry systems, including some syntropic agroforestry. So, but let's come here to the conclusion, because I think Andrew Millison sums it up really good. As permaculture moves forward outside of Australia, United States, and Europe, it's obviously going to need to change these rules into more like guidelines for specific ecosystems.
By any means. And I'd be really curious about what Bill Mollison's prescription would be in a land-scarce and people-rich area where extreme slopes are currently being cultivated. So now we're going to look at a typical foothills landscape.
So that's his conclusion. We'd be very interested to know what Bill Mollison would think. I think Bill definitely added, his 2 cents and more. Valuable information. The key here is the infinitely varied part. I keep thinking about these different strategies, and we're going to work out a framework by which underneath design systems we have strategies so we can tease out this jargon, but it's not clear to me that there is going to be one best strategy, even for a specific climate ecosystem. It's not clear to me that it makes sense that everyone in the same watershed is using the same strategy. There may be pieces, techniques of the strategy that make sense in a comprehensive way, but farmers should be doing different things. And especially if we're experimenting, they should be on the edges experimenting and pushing forward their specific strategy. But ideally, different neighbors would be doing different strategies. Some of them could be replicatable, but across watersheds or across regions, ideally there would be 10 strategies or 20 strategies even. And that comes back to market forces. If we all grow the same thing, the price of that thing is going to go down. That's something that we'll talk about with markets and farming, which is the analysis. The analysis is really interesting. So, but I think Andrew correctly identifies the issue. Bill Mollison, I don't think is going to be up giving us, unless some hidden writings. I mean, obviously, Bill, rest in peace, Bill. You did great, but it's us. We need to add on, and so I think that I'm in a special position in one of these different steep sloped areas where people have been cultivating for hundreds of years and even thousands of years to design different strategies for these slopes, because they're not going to stop because somebody in Australia said, oh, that's too steep. They're not going to stop here. We've been doing it. And yes, there are problems with erosion and acidification of soil, but there's solutions, especially when we slow the water down. We can correct acidification, and we can really prevent erosion quite well. So those are my thoughts. Thank you, Andrew. We're going to be going through some more steep slope videos on YouTube, doing the reaction videos, and starting to put in a framework. The entire framework, we're going to be working on jargon, but also defining the holes, right? Where the current best practices need to elevate themselves conceptually, like with steep slopes. It totally makes sense in Australia, and even nowadays people are saying this doesn't quite make sense. I, as a permaculture practitioner in one of these climates and ecosystems with steep slopes, hope to add my 2 cents in, and we can continue to make the world a better place. Thanks.